Hi, geometry students, and welcome to Tuesday, January 12th. Hard to believe we have just about gotten halfway through January, and I haven't even seen you in the new year. So I am providing a lesson here for 5.2, and we are going to be learning some new postulates. And these postulates now are going to start providing us with additional information that are going to help us in some proofs. So if you look ahead in this chapter, you see that we are getting back to writing some proofs. And we did those just on a little bit earlier, but I like to introduce it earlier in the year so that when we get further into the chapter, you've already been introduced and you already have the mindset of doing it. So let's begin with page 241. And on this page, they give you a little activity. You can recreate a triangle if you want to. So I'll leave that up to you. However, we're going to jump right in on postulate 12. And this is pretty easy. It's the SSS. Postulate, side, 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 congruence postulate. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So here is that postulate on page 241. It is as simple as it sounds, but you need to remember it. You may write it SSS on a test. You may not write postulate 12. Remember, Mrs. Jernigan does not like to have to go get her index cards out of her bag when a student tries to write the theorem number or postulate number. I want you to know the title. I want you to know what it does. And so in this case, you can write SSS. You do not have to write side, side, side. So it shows us here that three different sides. So we have the red sides. Right there, they're congruent. The blue sides, they're congruent. And the green sides, right there, they are congruent. It's the same thing that's in your book, so if you're not sure, it's pretty easy though, then check it out. All right, the example that follows that asks a question. So your homework is going to ask you questions. And they'll probably be along the lines of, does the diagram give enough information to show that the triangles are congruent? So you're going to have to do a little bit of thinking, put the thinking cap on. So we look at this, and they do give us some information that shows us that there is some congruence already going on here. We know that HJ, so we start over here and naming it HJ, is congruent, that means we have to start over here, to LJ. Very good. Then HK is congruent to LK. Okay, so we find out we've got these two sides are congruent, but we have this third side. Well, if we reach way back into the, I don't know, maybe first quarter, early second quarter, we learned about the reflexive property. Remember that one? So we're pulling on something else to help us solve this dilemma. We know that JK equals JK, or is congruent to JK. That means that yes, we have enough information now to say that SSS congruence works here. But we did have to pull out a little bit of information from a previous definition or property. So you're going to start doing that more, just to give you a little hint. All right, let's look at the next one, postulate 13. You may call this one SAS on a test. You do not have to write side angle side congruence postulate. You may if you want, but SAS is sufficient. Now what that means, if two sides, so here's PQ and RQ, if two sides are congruent to two sides of another triangle, and the included angle of a second triangle, or the included angle of both, then the two triangles are congruent. Now, what does it mean by included angle? It means the angle between those two congruent sides. So if PQ and QR, angle sitting between those would be the congruent. And so PQ is congruent to WX. Then we have QR is congruent to XY. That means the side or the angle in between them, angle Q and angle X, if they are congruent, then we can say that we can use the side angle side to indicate that they are congruent. So remember, in trying to establish congruent triangles, we have now SSS and SAS. So hopefully that's pretty easy to use. All right, so now they want you to use the SAS postulate to see if we have enough information to determine. So if you, again, my wonky picture, but this is on page 242, so you can take a look at it. So they give you your two triangles. We've got A and B, so we'll do A first. And we find out that we have AB is congruent to CB. Remember, I can't say AB is congruent to BC. I've got to work from mirror images. So AB is congruent to CB. And then I have DB is congruent to DB, and that's just the reflexive. So we use the reflexive. So if you were writing a proof here, you'd have to tell me reflexive policy or reflexive property. Then we also find out that both of these are right angles. Well, it shouldn't take us too much to determine that right angles are congruent. So we could write there that CBD is congruent to ABD because we know that they're both right angles. Then we could say right angles are congruent, however you want to do that. But yes, we have enough information to determine that these are congruent. So let's now look at the next one. So I like to pick everything apart. So I can say that GF is congruent to GH, just merely by what they give me. I can also say that GE equals GE because of that old reflexive property that keeps popping up. However, the angle in between them, right here and right here, I don't know anything about. And so I cannot determine that those angles are congruent. Therefore, I cannot use the SAS congruence postulate in this case. Okay. Let's move to the next blue box, how to write a proof. And we've actually already worked on this a little bit. So I introduced you early to proofs, and then, here we are again with them. So I'm just going to go through what they give you here, and we're going to do one together. And then hopefully, as you review those index cards and we play the unfair game with those index cards on Wednesday, they'll jog your memory because you really need to start memorizing them now. So I would suggest that you every day when you get your homework out, just look at them and just look at the title. Remind yourself what it means, and be trying to memorize them. So let's start. So the first thing, when they give us a proof, they always give us some given information. And so make sure that you look at the diagram, and they might not give you the given information in words, but they might give it to you in symbols. When you see the congruent symbols, that's given information, even if they don't say it in words. So look at everything. And that's the second point. Use the information from the diagram. Give a reason for every statement that you make. Now, you might solve a proof in 10 steps, whereas the person next to you might solve it in 5, and they might both be right. But as long as you give the information, then it really doesn't matter. So use all your information. Use all definitions, use all postulates, theorems, and reasons. Anything that we have done in the course of this year that falls into those categories, information, definitions, postulates, theorems, reasons, any of that, make sure that you have put that on index cards. Go back as you review for the Wednesday Unfair game. Go back. Make sure you've got them all. They're in blue, little blue boxes. List your statements in order, because if a statement relies on something previous to that, then I need to see the logic of your thinking. Geometry, more than any other subject, is going to teach you how to think logically, even more so than your logic classes, but hopefully it kind of all works together. And then finally, end the proof with the statement the proof with the statement that you're trying to prove. So they always tell you what they want you to prove. I always make it my last, I just put it far down, and that way I remember where I have to land. It's kind of my flight plan. So remember that, what is it you want to prove? That's your flight plan. Put it and then move forward. Okay, let's take a look at example number 3, where it says they want you to write a proof. And I've already shown you how to do this, so I'm not going to go through the logistics of making the chart with the statements. And you can set it up however, as long as it sort of makes this kind of sense that we're showing here. So they tell you, we want you to write a 2-column proof that shows that JKL is congruent to NML. So I'm going to take a good look at all of this information. I've got JKL and NML. Okay, they want me to prove that those are congruent. All right, good. They tell me that JL is congruent to NL. Okay, great. I'm also going to make an assumption now that L is the midpoint of JN. I might need that, I might not, but I'm probably going to write it down somewhere. They also tell me that L is the midpoint of KM. That means that some other things are going to be equal here. I'll let you think about that. And here's the thing they want me to prove. So that's going to be the last statement on my little set of columns. So, proof can be set up in 2 columns. It begins with the information and ends with the statement you are trying to prove. So let's start it. I've just done a little bit at a time. So here's your little chart, statements, reasons. Sometimes I will write proof over here. Whatever you write here, I'm going to know. All right, so first of all, we always, most of the time, are going to start with given information. So I'm going to go ahead and put given information. And so they remind us that JL is congruent to NL. That's great. And then L is the midpoint of KM. Okay, so we have to remember that. And so they've put that as a given as well. All right, let's move on. Now, they're going to jump right in, and they're going to say that JLK is congruent. Let me do JLK is congruent, and I think it is to NLM. NLM. Okay, so let me see, did I miss some steps here? No, okay. They're going to jump right in. Let me get back to that one. Okay. The information is from the diagram. So they're actually giving you, these are given statements. This comes from the diagram. So, excuse me, it's the angles. The angle of JLK is congruent to the angle of NLM. So now let me hop back up to the diagram. Should have put these on each one. And so JLK and MLN are congruent. Now hopefully you know why that is. Well, it's vertical angles. We did that a while ago. Vertical angles theorem, and we've got congruent angles. Now let's go to the next one. We've already talked about this, but KL is congruent to ML. Here it is, KL, congruent to ML. And that's because we know that that L is the midpoint. That's going to make those equal. See how you can just crank along, but you're using stuff. Midpoint was early in the year. Vertical angles theorem wasn't far behind it. So these are from way back. You got to dust the cobwebs off and see how we use these things all year. So you can't just write them down and forget them. You got to keep studying them all year long. Okay, then let's move to the next one. Well, now we can say SAS congruence postulate because we have, let's go back to up here. We have stated that this KL and ML are equal. So if I had a little magic marker, I could put in my congruence equal segments there. We also stated that JLK and MLN are equal. That means we have side, angle, side, side, angle, side. So there we have solved our proof and we use the SAS congruence postulate. So hopefully you brush up on these index cards. You do have a couple little proofs that you're going to work on. There's another one on page 244. I'm not going to go over it with you. We can in class if you're still struggling on Wednesday, but I want you to read it. Then you can also try the checkpoints before you actually dive into the homework. But you do have a couple in there, and I will plan to go over them. I'm only planning on one new lesson on Wednesday because I do want to play the game and brush up on the index cards. So I look forward to seeing you tomorrow, and just let me know if you have any questions on any of this material, and I will see you then.